Okay, class, thank you for tuning in for stats number 3. This is the third video in our sequence on basic statistics. In the previous two, we talked about observational studies, where basically we're doing observations on a population, and we choose a sample, a representative sample. Hopefully it matches our population and the relevant characteristics, and we observe them, so we learn something about them. But in this video here, we're going to talk about experiments. So in the difference between experiment and observational studies, we're going to actually do something to the group and experiment. We're going to experiment on them. And the important setup to this is we need to have two groups, a treatment group and a control group. The control group thinks they're in the experiment. They're treated the same as the experimental group, but they actually receive a placebo. They receive a fake version of the treatment. And this is very important that we have these two groups. So let me give a quick example that might illustrate why. Let's say you have a condition, and I say, hey, I've got a new medicine, new drug for you, and this medicine will cure your condition 25%. 25% likelihood it'll cure your condition. How good is that? Are you happy with my new medicine? Hey, give me that medicine. In fact, it has bad side effects. Your hair's going to fall out, you're going to have bad headaches for 2 months, but it will cure your condition 25% of the time. Is that a good medicine? We actually have no way of answering that question until we have some information about a control group. For example, let's say that the condition you have is fatal 100% of the time. So the control group, 100% dead. So obviously a bit morbid for my example, but you're getting my point. Now a 25% cure looks pretty darn good. It's okay, it's 1 in 4, but your other chances are 0 in 4. So what the heck? Who cares about the side effects? This is the best shot you've got. So as bad as that sounds, that would actually be a good study. We'd say, well, 25%, that's a heck of a lot better than 0%. But if instead the cure group, the control group rather, had a 24% cure rate with no side effects, you might say that to get a 1% better cure, you might just take the sugar pill or do nothing. In other words, this medicine does not look terribly effective. Statistically, it might not be doing a single thing for you. That could just be a random difference. The numbers are so close together. So we have to know something about the control group in order to evaluate how good a treatment group, how good that number even it means to us, what it even means to us. A placebo effect is the effect when you think you're being treated for something. In fact, in some studies of medicines, people have had such bad reactions to fake pills where they're getting nothing because they're expecting something to happen. And if the two groups are treated the same, the doctor may have told the person receiving the placebo, you may get really bad headaches from this pill. Of course, the pill is not causing the headaches, but in your mind, once your mind starts expecting something like that, it can have a very strong effect. If your mind expects you to get better, that's also important. So that's why we need two groups, one that thinks they're being treated but is not, and one that is being treated. Now, how we're going to treat these groups brings up the concept of blind and double blind. Blind is when the experimental subjects and the control subjects don't know which one they're getting. Otherwise, it's kind of useless. If they actually know they're being treated, they'll have different results than if they don't know, if they knew they're not being treated. But in just a blind study, a single blind study, the experimenter would actually know who's getting which treatment. Problem with that is, let's say I'm the experimenter, the way I treat you could be different. If I know this pill is really powerful and it's going to really have a change, I may speak to you and in nonverbal ways communicate my confidence in the medicine to you differently than I do the placebo group. So that brings up the idea of a double-blind study. In the double-blind study, I wouldn't know which group is getting which pill. The pills maybe are just numbered, and obviously someone has to know somewhere. We can't just randomly hand out pills and lose track of what we're doing. But I'll just record a number. So patient A gets number 1, and patient B gets number 2, and I don't know which pill is which. So I read a script, and that way I have no reason to treat them differently because I don't know a single thing about which one's getting the real pill, which one's getting the fake pill. And for our purposes, when we're reading about experiments, we really want to see a treatment group, a control group, and a double-blind study. Those three together get us on the right track to believe maybe we're seeing some good results. Now, I want to mention one other kind of study, a case control group. Case control group comes up a lot, and that's that in many things you're interested in studying, the groups actually pick which group they're in. The subjects actually pick. So for example, let's say I want to study the effects of smoking on pregnant women. I really can't do this experiment. Ethically, morally, it's going to be impossible for me to take a group of pregnant women until 100 of them, okay, you guys smoke a pack of cigarettes every day, and you guys don't smoke a pack of cigarettes every day, and we'll compare your baby's health. Obviously, I would probably be violating some research ethics standards to do such a thing, so you can't do that. But people make those choices already. Some people smoke, some people don't during pregnancy. So we can get data, and the reason it's case control is the individual cases that we're looking at have already controlled which group they're in. They made their own choices. But there is a problem with that. If we look at that past example and we separate the smokers from the non-smokers, are we sure these two groups are the same, or is there a bias? And we saw in video 2 how important biases are. Are there some bias differences in these two groups? And so by that I mean, are there other characteristics that are perhaps different between smokers and non-smokers during pregnancy? Do you think you would see a higher level of drinkers in one of these two groups? A higher level of people who were very happy to be having a baby and thus doing great prenatal care? Of course, there will be differences. Lifestyle choices are huge choices that kind of run together. So certain people make certain good choices or bad choices in groups together. That's not to say that all the smokers are drinkers, just we might find more drinkers in this group than the other group. And so if we see a different result between our treatment group and our control group for this case control study on smoking and pregnancy, we don't really know if the different results in the baby's health is due to the smoking or some other factor that's hidden that we didn't actually study, but is different between the two groups. That's called a confounding factor. I've had tests where students have written confusing factor, which is fine, you have the concept. It is confusing your study, it's something outside of what you're studying. So you get results on smokers and non-smokers, and the babies look different in some health attribute that we can measure, but we're not really sure, and we have to be very, very careful with these case control groups, because there may be biases in who's selecting into which group on different factors. Even in a treatment and control group for an experiment, if you have a new medicine that's real good, it might be tempting to give the medicine to the sicker people. After all, you have this new medicine and you think it's really effective. That would sort of ruin your results. If the sicker people are in here, this group is not the same as that group. So we're always on the lookout for bias in all of our statistics. And we as consumers of information have to be on the lookout for bias in reports, particularly on case control groups. One group does something and gets some result. Is there some bias in who was selected for which group or the people who choose that? I hope this has cleared up some of these new terms, and in our next video, we're going to give some practical examples when seeing statistics and numbers in the news that can tell us which studies are really worth giving a lot of importance to and which ones we can kind of throw out as fluff in the news directly.